So here, chemistry paper 4, Feb March 2021, 06-2042. In question 1, he is asking about the table is given and the number of protons, neutrons and electrons are given. And he's asking different questions. So first, I think we should write the electronic configuration so that it is easier for us to answer the given questions. So for first, it has just one proton, one electron, and after that it become anion, a cation. So B is 6, so it means first orbit 2 and the second orbit 4, again 2, 4, here is 2, 8, and then 2, 8, 6, then 2, 8, 7, then 2, 8, 8, and after that 2, 8, 8, 1, then 2, 8, 8, 2. So here's the basically electronic configuration. So now it's easier for us to solve the question. In A part, the first is an anion. What is an anion? When an atom loses or gains electron. So it's basically when an atom gains electron, then it converted into anion. After gaining electron. So look at this. So here the E, look at the E. So E has different number of protons and electron. It has 2 more electron. So it's mean that E basically gains 2 electron. So E is anion, and cation means when an atom loses an electron. So it's mean number of protons are greater than the number of electrons. So look at the answer. A has 0 electron as compared to proton. So A, and look at the I, 20 and 18. So electrons are less than the protons. So it's mean that I loses 2 electron and convert into cation. So A and I. And noble gas atom. What is a noble gas atom? Means noble belongs to group number 8 or 0 group. Group number 8. So it's mean that it contain 8 electron in the last orbit. So D. Look at this D. So a noble gas atoms D and then G, because both D and G contain 8 electron in their last orbit. So it's mean they are stable. And then is a question 4 is an halogen atom. Halogen atom means group number 7. So group number 7 means any atom that belongs to group number 7 have 7 electron in their last orbit. So look at this F. So F contains 7 electron in their last orbit. So it belongs to group number 7. And after that is a group 1 atom. Group 1 atom, not ion. Well, look at the H is a group 1 atom because it contains 1 electron in their last orbit. Look at this, 1 electron in their last orbit. So that's why the H belongs to group number 1. So H is here. Have a same nucleon number. What is a nucleon number? Nucleon number, sum of the protons and neutron number. Have same number of neutrons and protons. So here look at the G. Look at the G. When we add protons and neutrons, so 18 and plus 22. So it will give us 2 and 8 to 10, 2, 1, 3 and 4 here, 40. And then look at the I. For I, 20 plus 20, 40. So it's mean that G and I has same nucleon number because the sum of the proton and neutrons are equals to 40. And question 7, cause acidity in aqueous solution. Acidity means when an atom loses its proton. Proton means hydrogen ion that cause an acidity in solution. So look at this. A that contain 1 proton. So it's mean that A causes acidity in aqueous solution. Question 8 is used to define the relative atomic mass of an element, that is carbon 12. Carbon 12. So it's a 6 and 6 here because 6 plus 6 is 12. Here the 6 is the proton and 6 is the neutron. So sum of the neutron and proton is equals to 12, and that is the atomic mass of carbon. So it's B. Explain why B and C are isotopes of the same element. Isotopes mean they are same atomic number. Look at the C. He's basically asking about the B and C. They have same atomic number because they have same atomic number, have same atomic number. Atomic number means number of protons, but different nucleon number. Different nucleon number or different number of neutrons. You can say that. Proton and neutron. So here's the question. The question 1 contained 12 marks. So here's the question 2. The elements shown are gases at room temperature and pressure. So these are the gases. So you know that hydrogen present as H2, nitrogen, N2, oxygen, O2, chlorine, Cl2. So these are the gases. In part A, state which one of the gases is green, and you know that chlorine is green gas. Chlorine is green gas. Sorry for that. So chlorine is green gas. And then the gases shown and exist as diatomic. Look at this: H2, N2, O2, Cl2. So these are all these gases are diatomic. He said, state the name of the other element which has diatomic molecule and is gas. So diatomic group number 7, simple as that. Fluorine. Fluorine exists as diatomic gas. So when separate sample of each of these gases are placed in a container, they will diffuse. Describe why these gases diffuse. Because due to constant random motion, they will diffuse. Next one is, state which of these 4 gases has the highest rate of diffusion. Highest rate of diffusion is mean that diffusion, the factors that affect on diffusions are temperature and molecular mass. The basically relative molecular mass, MR. So here the gas is hydrogen. Why hydrogen? Because it has lightest relative molecular mass. It has lightest relative molecular mass. Yes, you know that molecular mass of the hydrogen is 1. So it has 2 hydrogen. So 1 multiplied 2, it has 2 relative molecular mass. So in D part, nitrogen, oxygen and other substances are found in clean dry air. State the percentage of the nitrogen. You know that nitrogen is present. The most present gas in air is nitrogen, so 78%. Other than the nitrogen and oxygen, identify another element found in clean dry air that are basically noble gases. Noble gases are rare gases. You can say that argon, neon. So these are the gases are present. Helium, you can say that helium. These are the gases are present in clean dry air. Identify a compound present in clean dry air. Compound that are chemically combined together. So water vapors and carbon dioxide. So 4 part is, nitrogen and oxygen can be separated from liquid nitrogen. State the name of this process. So the name of this process is fractional distillation. Fractional distillation. Fractional distillation means due to the difference in the boiling point, we can separate these gases. So here we are. So here's the question 3. In question 3 is asking about nitrogen react with hydrogen. So nitrogen react with hydrogen. So here's the reaction. So name this industrial process. You know that in the preparation of ammonia from nitrogen to hydrogen is an industrial process, and the process name is Haber process. Haber process. So name the meaning of this. It's mean that reversible. Reversible. State the condition for Haber process. The temperature is 450 degrees centigrade and 200 atm is the pressure. State the catalyst used for Haber process. Iron is used as catalyst. Iron Fe. If the pressure is increased, the yield of ammonia increases. We know that pressure increases. Pressure linked with the number of moles favors the number of moles. So when we increase the pressure, the equilibrium will shift to that side that has less number of moles. So look at this equation. On the left side there is 1 plus 3, so total 4 moles on the left side and 2 moles on the right side. So it's mean that when we increase the pressure, the equilibrium shift toward right. Why right? Because right side contain 2 moles as compared to left side. So position of equilibrium shifts to right because there is less number of moles. So next one is, if the temperature is increased, the rate of reaction increases. Wow, when temperature is increased, you know that here's for example temperature, the particles start moving faster. They start in vibratory motion. So they will collide with each other and with the wall of the container. So it's mean that most of the particle gain enough energy to react. So it's mean that they gain activation energy for the reaction. So we can write this point. So kinetic energy, when you increase the temperature, the kinetic energy, the energy due to motion, they will start move faster. So kinetic energy of particles increases and the particles move faster because it has more kinetic energy. And after that you can write the rate of collision because particles now moving faster, so they will collide with each other more frequently. So rate of collision increases, and after that particles have sufficient energy to react. Okay, in part B, ammonia react with sulfuric acid. So how will ammonia react? Ammonia is NH3, sulfuric acid is H2SO4. So he basically uses a fertilizer. So now we are going to write ammonia. So after reaction it become ammonium ion, it convert into ammonium ion, and the sulfate that has a -2 charge on it. So by using crossover method, so we can write this positive one, the one is shifted toward sulfate ion and -2, so it becomes sulfate 2. This 2 is shifted under NH4 and sulfate ion, so it become ammonium sulfate. So here is question 4. In question 4, the basically student want to make zinc chloride crystal. So zinc chloride crystal. So the student here the steps. The step 1, he's adding zinc powder to dilute hydrochloric acid. zinc powder to hydrochloric acid to form zinc chloride. In step 2, you remove unreacted zinc powder from zinc. So that is the removal, and you can remove by filtration. By filtration process, heat the solution. So here is an heating, and the next and last step is cooling, and you know that cooling form crystallization. Write the equation for the reaction step 1. So in step 1, the basically zinc powder is reacted to hydrochloric acid and forms zinc chloride plus hydrogen gas. Now we are going to balance. So look at the right side. There are two hydrogen, so we should multiply the 2 here on the left side. So here zinc 1, so zinc 1, the hydrogen 2, Cl2, Cl2. Explain why excess zinc powder is added in step 1 to ensure all acid is fully reacted, because there is an acid. So we must use a zinc powder in excess to ensure that all acid is being fully consumed. Suggest why unreacted zinc powder is removed in step 2. Unreacted zinc powder is removed in step 2. So why we should remove this zinc powder? How this unreacted zinc powder is being removed? You know that there is a process known as filtration to remove the zinc powder. The next step, a saturated solution formed in step 3. Saturated solution. So we know that what is the meant by term saturated solution? Saturated solution means that solution that cannot dissolve anymore solute at given temperature. So it's 2-mark question. You know that the 1 marks for this portion, anywhere does not dissolve any solute, and the second one is for the condition at given temperature, because you know that solubility temperature affect the solubility. When you increase the temperature, the solubility increases. When you decrease the temperature, the solubility decreases. So next, in E part, explain why crystal form as solution cools. And you know that cool, solubility decreases. Solubility decreases as the temperature decreases. So name 2 zinc compound which react with dilute hydrochloric acid to form zinc chloride. So name any 2 zinc compounds. So you can write zinc oxide or zinc hydroxide that contain basically zinc. So these are the compound that contain zinc. If excess calcium metal is used instead of calcium powder, pure calcium crystals do not form. So why? So if we use, there will be the formation of calcium hydroxide because our acid is aqueous, so that contain water. So when we use calcium metal, then they form calcium hydroxide instead of calcium chloride. So we must use a zinc powder to ensure that there should be formation of zinc chloride instead of zinc. So here's the B part. Some salts can be made by titration by mixing an acid with a base. That is known as titration. So here's a base. And here is acid. When acid and base is mixed together, they form salt and water. So that is known as titration. So the amounts are given. So look here, here's the volume. The volume is given of sodium hydroxide. the volume of sodium hydroxide is given, and that is the volume, again volume, and that is known as molarity, or you can say that it's concentration or molarity, the number of moles per decimeter cube of dilute sulfuric acid to make sodium sulfate. Sodium sulfate is Na2SO4. So circle the name and type of the reaction that take place. So that is when an acid react with a base, that is neutralization reaction. That is neutralization reaction. Okay. So in second part, calculate the concentration of, we have to calculate the concentration of aqueous sodium hydroxide in gram per decimeter cube. In gram per decimeter cube, using the following step, calculate the number of moles. So here the first step. So we are going to solve the first step. Calculate the number of moles. So we have to find the number of moles of which? Dilute sulfuric acid. So for finding the number of moles, we have two formula. Moles is equals to mass divided by mR, or molecular mass. But you know that there is no mass. This question is dealing with the concentration and volume. So here's another formula, that is moles is equals to concentration multiply volume. So in this way you can find the number of moles. So you can write it like this: N is equals to C multiply V. So N is equals to C is the concentration of dilute sulfuric acid. So look here, concentration of dilute sulfuric acid is 0.100. That is concentration. That is concentration of dilute sulfuric acid. So its concentration is 0.100 mole per decimeter cube. You can even solve without writing the unit here, but I'm going to write this due to the issue that volume has centimeter cube. So I'm going to convert the volume into decimeter cube. You know that if the units are not same, you can't solve the question. So here's the volume, but look at the volume. Its unit is centimeter cube. So you have to convert the centimeter into decimeter cube by dividing with 1000. Now you can solve it. Now it's converted to decimeter cube. Now after solving this, it become equals to 0.0025 moles. Okay. In the next step, determine the number of moles of sodium hydroxide which react with the dilute sulfuric acid. So you can check that you can't solve the number of moles by using these two formula, the first, the second, because you don't have a concentration of sodium hydroxide, you don't have mass of sodium hydroxide. So there's another way. If you know the number of moles of any one substance in the reaction, here's the reaction. In any one substance in this reaction, you can find easy number of moles of another reactants or products. So here we know that concentration of sulfuric acid. So we can compare the number of moles of sulfuric acid with number of moles of sodium hydroxide. So look here, the number of moles of sulfuric acid is 1 in this equation. So look here, it's 1, and the number of moles of sodium hydroxides are 2. So I'm going to write here 2. So we know the number of moles of sulfuric acid. We already find it. Look here, the number of moles of sulfuric acid. So I'm going to write as 0.0025 ratio. So here we are going to multiply it with 2 because it's double. So we can make this 0.0025 double by multiplying it with 2. So after multiplication, it becomes 0.005. In question 3, calculate the concentration of aqueous sodium hydroxide. So we have to find the concentration. So again, we can use the formula N is equals to C multiply V. Concentration. So here's the concentration. We have to find this concentration. We know the number of moles as we already find this. 0.005 is equals to concentration and multiply volume. Volume is 0.25. The volume is 0.05. Sorry. is 0 point is 0 point is 0.02. So volume is here 0.02. Why? Here, look at this. The volume is here 20 centimeter cube. So centimeter cube. So you have to convert into decimeter cube by dividing with 1000. So after dividing it, it becomes 0.002 volume. So we have to find the concentration. So concentration is here 0.005 divided by 0.02, and it becomes 0.25 moles per decimeter cube. So in the next step, he said calculate the concentration of aqueous sodium hydroxide. So in gram per centimeter cube. We already know the concentration, but this concentration is mole per decimeter cube. Now he said find the concentration in gram per centimeter cube. So we have to convert mole per decimeter cube into gram per decimeter cube. So for converting mole to gram, the decimeter is same, but we have to just convert the mole into gram. For converting mole to gram, we have to multiply with molecular mass of that substance. So here's the sodium hydroxide. So we will find the sodium hydroxide molecular mass, NaOH. The mass of sodium is 23. The mass of oxygen is 16. And for hydrogen is 1. So when we multiply it with the mole 0.25, that is the concentration, the molarity or the concentration, multiply 23 plus 16 plus 1, that is the MR of sodium hydroxide. Then the answer will be 10. Okay, so it's 17 marks question. And next question, that is organic chemistry. So this question belongs to organic chemistry. So in this question, he's basically asking about, look at there's a substances P, Q, R, S, T, U. Give the letter of organic compounds P to U that belongs to unsaturated hydrocarbon. You know that unsaturated hydrocarbons mean carbon-carbon double bond, and saturated hydrocarbons mean carbon-carbon single bond. So look at this carbon-carbon double bond. So here is carbon-carbon double bond. You know that when this word ends with ene mean double bond. Ene mean single bond. Ine mean triple bond. So here ene, so it's double bond. So first is R. We can look here. Look here, U. U also has double bond here. So R and U. Now it's B part. Describe the test for unsaturated hydrocarbon. Unsaturated mean we are going to check that either the given substance is singly bonded substance or double bonded substance. So for checking this, we can use bromine. Bromine, that is the single test in your syllabus. You must memorize this. Okay, and bromine water, we have to add the bromine water in the solution of unsaturated hydrocarbon. Then bromine water color is orange. Its original color is orange. Then it's turned to colorless. It become colorless after reacting with unsaturated hydrocarbon. So in the next part, but1ene. So but1ene, look here, but1ene, 1, 2, 3, 4, that is but, 4 carbon. 1ene mean at the first position there is double bond. At the first position there is double bond, and you know that all the other bonds, all the other valencies are basically, sorry for that, there is just, because carbon has a valency of 4, so 1, 2, 3, 4. So this carbon is satisfied with 1 hydrogen. So here, So what he was asking for, name the unbranched isomer of but1ene. So isomer mean the same molecular formula but different structural formula, and but he said it must be unbranched. Unbranched mean there must be a linear. So just we can shift this double bond position from first position to second position here. So the double bond will change to second position. So its name is now but2ene. But2ene. First, two, second, third, and fourth carbon. So it become now but2ene. The two basically representing the bond, the double bond position. So that is but 2ene. Okay, next draw the structure of branched. Now we have to draw the structure branched structure. So here, so we have four carbons, 1, 2, and 3. So it will be branch. So I'm going to make a branch over here. So carbon. Now double bond any place for, I'm going to write here. I'm going to mention the double bond here, branched isomer. So all the other carbons are now hydrogen, 1, 2, 3, and the fourth hydrogen here, 1, 2, 3, 4. So this carbon is satisfied. 1 for this carbon. So 2, 3, and 4 hydrogen. So 1, 2, so there will be 2 hydrogen. Okay, in the next question, dudecane is dudecane means 12 carbon. 12, no, he's mentioned here, he mentioned the 12 carbon atom. Dudecane can be cracked mean we can break down dudecane by giving heat. So write the formula of the dudecane. Simple, is ending with ane, A-N-E. So it's basically mean that it belongs to the family of alkane. So we can easily, the general formula for alkane is CnH2n plus 2. So when C12, H become 2n, n is 12, so it's H basically plus 2. So 24 plus 2, it will be 26. Now again in the next part he said, give the letter to all organic compound Pu2 that can be cracked. Give the letter of our organic compound Pu2 that can be formed when dudecane is cracked. So when dudecane is cracked, you know that it must form alkane and alkenes. So it will be P, the alkane, it has 3 carbon, and then R, it has 4. So 3, 4, and 7. So we need 1, 2, 3. So 3, 6, and 6, 4, 10. So we'll multiply it with this. So P, R, and U. P, R, and. So in the next part, he said name a reagent and suggest the condition needed to convert an organic compound U to organic compound S. So what is U and S? U is alkene and S is an alcohol. So U is alkene and S is alcohol. So we have to break the double bond and convert into an alcohol. So it's mean that we need water, because when double bond is there's no more double bond after converting into alcohol. So both carbon needs one more bond. So we need water, but the conditions are 300 degrees centigrade. It's mean that we can't write water over here. Okay, so we don't write water over here. because water is now converting into steam. So you can't get the mark if you write water over here. You should write steam. So the temperature is 300 degrees centigrade. Pressure will be 60 atm, and then phosphoric acid. Phosphoric acid. These are the conditions to convert an alkene to alcohol. Okay, in the next part F, organic compound S can be converted into Q. So S to Q. Name the type of the chemical chain that happened to organic compound S. So what is S? S is an alcohol. Look here, S is an alcohol and Q is an carboxylic acid, double OH. So it's mean that we have to convert an alcohol to carboxylic acid. So it's mean that we have to add an oxygen. So adding oxygen is known as oxidation. Adding oxygen is known as oxidation. So this reaction is known as oxidation reaction. Name the acidified reagent added to organic compound S. So simple is that. That is acidified potassium, acidified potassium manganate. 7 solution. Acidified potassium, its formula is, I'm going to write the formula over here for you, KMNO4, acidified potassium manganate solution. Basically acidified potassium manganate, what they did, they basically produce atomic oxygen, and that atomic oxygen will convert the S compound to Q compound, S to Q. Okay, by reacting, the S compound will react with this atomic oxygen that made by acidified potassium manganate to convert into Q. So that's why we need acidified potassium manganate. So in the next step, G, organic compound T is made by reacting two compounds together. T, reacting compound. Name the homologous series that organic compound T belongs to. So T is methyl butanoate. Methyl butanoate. So it belongs to methanol. Methanol. Homologous series methanol. Okay, the homologous series. So in the next part G, organic compound T is made by reacting two compounds together. Name the homologous series that organic compound T belongs to. So T is methyl butanoate. So that belongs to the family of esters. So in the next part, name the two compounds which react together. Now it will explain that how it belongs to esters. Name two compounds that react together to make organic compound. Draw the structure of each compound. You have to name, show all the atoms and the bond. So the first, look at the first species is methyl. So it will be methanol. Methyl is methanol. Methyl belongs to methanol. Okay. And the other one is butanoic acid. Butanoic acid. So when alcohol, that belongs to the family of alcohol, and that belongs to the family of carboxylic acid. When alcohol and carboxylic acid react together, look here, the methanol we take methanol from alcohol family and acid from carboxylic acid family. When an alcoholic family compound and carboxylic acid compound react together, they form a new compound that belongs to the family of ester. So esters are basically made up of alcohol and carboxylic acid. So we have to draw the structure. Metha. So that is just one carbon compound. So one and functional group is OH, methanol. So OH. So all the other bonds are satisfied with hydrogen. So here, and the next one is butanoic acid, and you know that the carbon that is attached with OH, C double bond O. So you can write over here C double O A H. So that is also. So here's the first carbon and the 3 more carbon along with it. So here's the 3 more carbons. So the total carbons are now 4. So we have to make hydrogens over here. Hydrogen, 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 hydrogen. Okay. So that is butanoic acid. In the next part, deduce the molecular formula. Molecular formula is that shows the actual number of the carbon, hydrogen and oxygen or anything that any compound contain. Compound T contain. So T is methyl butanoate. So methyl butanoate. So we have to combine methyl and so I'm going to draw the structure of this compound. So C H H H, and here will be oxygen O, here's C and O, sorry for that. So there will be C double bond O, and there are 3 oxygen, 3 carbons are there. Okay, that is methyl butanoate. So methyl, so look here, methyl, 1 carbon, butanoate, look at this compound, that is butanoate. Okay, so methyl butanoate, that is the complete structure of this compound. So look at this compound, that when an alcoholic and carboxylic acid compound join together, they form methanoate. Okay, so we have to write the molecular formula. So molecular total number of the carbons 1, 2, 3, 4, 5. So total number of the carbons are 5. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So hydrogens are 10. Oxygen 1, 2. So oxygens are 2. That is the molecular formula of organic compound T. Okay, so molecular formula, you have to just write the total number of the carbon, total number of hydrogen and total number of oxygens. Okay, the question number 6, that is again organic chemistry portion, polymer, organic chemistry, and that question is from the polymer portion. Polymers, when monomers combine together, they form polymer. A large molecule split up. State the name given to the small molecules. Large molecules are known as polymer and small molecules are known as monomers. Monomers. When monomers combine together, they form polymer. The formula of the polymer is shown here. Here's the formula. And N is basically the number of the monomers. N showing here the number of monomers. So what he is asking in the first part, he said draw the structure of the small molecule from which this polymer is made. So draw the structure of this. So we have to draw the structure of this compound. Simple is that. This bond and this bond will come together, and you know that this is the bond when we break the double bond between them. So it again double bonded carbon, hydrogen, CH3, HCH3. That is the monomer from which the polymer is made. Okay. Okay, in the next part, show all the atoms and all the bonds. So I write here, state the type of the polymerization used to make this polymer. So this is the additional polymer. Additional polymerization. When there is only one product in polymerization reaction, this reaction is known as additional polymerization. But when there is a two product in the reactor, then this is known as condensation polymerization. The other product is water. With the removal of water, you can say that that is known as condensation polymerization. And here is that. So the three amino acids, the three amino acids, they combine to form a natural polymer. When these amino acids combine together, they form a natural polymer. And what's the name of that natural polymer? Protein. 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 Okay, the next one, and you must know the things before solving the question number 2. Complete the diagram. So we have to complete the diagram, and that is here. This box is basically here, this box is here. Okay, so we have to write here between them, the spaces are given, so we have to complete this diagram. So simple is that this is known as this process is hydrolysis. We have to remove water. So how can water is basically combination. So this is known as condensation polymerization. With the removal of water, you can convert these polymers into monomers, and this monomer name is protein. So how can we remove water? The water is basically HOH. So you must know that we have to remove water from we have to remove the OH compound, OH hydroxide from the carboxylic acid side, OH from the carboxylic acid side, and H from other side. So carboxylic acid side OH, H from amine side, H and OH. So we have to combine over here. So here in this side, N and H, just one H. Why? Because other H will go with OH and form water. So here on the other side it becomes C double bond O, N, H single bond. So this carbon will attach to the nitrogen, and they link together. So this monomers will link together by this bond. Okay, so again repeat this process. C double OH is removed, and this carbon is going to attach with the nitrogen. So nitrogen H is removed, and there's just one hydrogen. So here in the next step, C double bond O and S. So you must write a single bond at the end of these monomers here. So why? Because it's mean that these monomers are now going to attach with other monomers to form polymer structures. Name the type of the chemical reaction that take place when this natural polymer is converted. So you have to convert this natural polymer protein back to its monomer. So what we have removed? We have removed water from these monomers. So we have to give back water. Okay, and giving back water, a process known as hydrolysis. This process is hydrolysis. So here's your paper. So if you have any question, you can ask in chat box. Thanks for watching my video. Like and share my video.